Hold on a second. Okay. On this page, on the top, okay, it says, part 1, label the parts of this atom. Let's talk about what the word atom means. It means what, Will? Did you say something? What does atom mean? No. It's an indivisible particle, but we know it can be divided now into the subatomic particles. But an atom, by definition, is a neutral particle. Does that ring a bell? Okay. So whenever you see the word atom, and this is why vocabulary is extremely important. We're going to be doing a lot of different things today because we have a double. Atom. When you see the word atom, you need to automatically think of the word neutral. And then, okay, if we know it's neutral, those are really bad squiggly arrows. We know that it has no charge. And if it has no charge, that means the number of positives and the number of negatives have to be equal to each other. So what's the positive thing that's inside of the atom? The protons. So let's just write that up there so we have it. And when we say proton, you want to make sure that you know what the symbol for a proton is. It's a P with a little plus sign on it. It's positive. Okay? And a P stands for proton. Now, if you have positives, you also have to have negatives. And what are those little negative suckers called? Electrons. Electrons. Okay, and what is the symbol for an electron? E with a little negative sign. Very good. See, I knew you guys knew that. So if you are neutral, you have the same number of protons as you do electrons. Okay, now let's go to our picture down here. Label the parts of this atom. Look at this line. Just this line right here. Okay? That line is this whole section. What is that whole section called? Sophia, what do you think? Right here. That's the nucleus. Good. So make sure you write in nucleus. That was the easy one. All right. Now, we're going to skip to this line right here. What is that line pointing to? The orbital, and inside the orbital are the electrons. I'm going to make those electrons red just because I don't know why they are the same as what these guys are, but they're different than those guys. So go back to my pen and let's write, this is an orbital that contains electrons. And the word orbital is referring to a region of space in which we are going to find the electrons. Those are orbitals. Okay. Now we've got these black and white circles in here. Okay. Let's look at the white circles. What are the white circles representing?
Protons.
Okay. How did you know that the white ones were the protons? Very good. Okay, so because there are 3 of these, and I'm just going to color them in yellow, pink. Okay, I made them pink. Because there are 3 of them, and there are 3 of these red guys out here, and we know that the red ones are our electrons, then these must be our protons, because the number of protons and the number of electrons are equal when we have a neutral atom. And we knew that this was an atom. So these pink ones are the protons. Now, what are the black ones? Neutrons. I'm going to do it in green just because I feel like it. These are neutrons. And what's the symbol for a neutron? N with a little 0, because they have no charge. So So protons were positive, neutrons are neutral, electrons are negative. The protons and the neutrons are in the nucleus, and the electrons are in the orbitals. And this brings us back to what we did last week before we took a little hiatus. Hiatus is a little vacation. And we talked about the, I'm just looking for the notes that we did. It's right here. We labeled these. So you should know this chart, okay? The protons and the neutrons, both located in the nucleus. The protons have a positive 1 charge. I'll even put that in here. The neutron has no charge, and the electron has a minus 1 charge. So far, so good? All right. Oh. Okay. Moving right along. Good? Yep. Okay. You guys over here, Matt, you good? Yep. Jake, you good? Okay. Jack, you good? Because you were out the other day, right? I want to make sure you're okay. All right. The subatomic particle with no electrical charge is called the neutron. I'm going to put an N with a 0 there. The subatomic particle with a positive charge is called the proton. That's a P with a plus. And the one that is negative, Emma, is a electron. I like it. Okay. There are the same number of these two particles in an atom. Protons and electrons. Now, please pay attention to what you're reading, because when you read a question, and we're going to practice some questions here, when you read a question and it says in an atom, then you know it is neutral. If they, however, say how many electrons or how many protons in this ion, which is another vocabulary word we haven't tackled yet, then they are not going to be the same. And that's where we're headed, in that direction. So I'm emphasizing the fact that you have the word atom. Atom means they are the same. Also remember, this is just a kind of a review, when we do atomic notation, this number down here stands for the number of protons. What else? Atomic number. Good job. Number of electrons in a neutral atom. And there's one other thing I said that it stands for. Starts with an N. Nuclear charge. It's the nuclear charge because the only thing that's in the nucleus that has a charge is the proton. So it also refers to the nuclear charge. And this number up here, do you remember what those numbers are called? Or that number is called? Atomic what? Atomic mass or mass number. What's the difference between these two? It's all right. Anything you can think of, we'll build off of it.
I don't know which one it is, but one of them is the whole number and one of them is the decimal.
Okay, so there's something we can build on. What is the whole number? Which one of these do you think is the whole number? If you're wrong, it's okay. Kevin, you think the mass number is your whole number? What do you think?
I was going to say that the decimals, I think, are like the average.
They are. So let's just write that stuff down so we remember. So Kevin's right. The mass number is a whole number. It is the number of protons and neutrons. That's what the mass number is equal to. The atomic mass is a decimal, usually, and that decimal is an average of all the naturally occurring isotopes. I'm running out of room here. Okay? Which I could actually go down a little rabbit hole and ask you what an isotope is. Because we did isotopes. So let's get it on another paper. I know that this is a review. Go ahead.
Is an atom with a different number of neutrons then?
Okay. So they're the same atom, which means they're going to have the same atomic number, which means they're going to have the same number of protons. These are all the same, right? Same atom. They're going to, same atomic number, same number of protons, but they're going to have different mass numbers or number of neutrons. Let me give you an example of that. Carbon 12 and carbon 14. Both of these are carbon, so their atomic numbers are going to be 6. Those numbers are going to be the same. These numbers up here are mass numbers. This guy has a mass of 12. This guy has a mass of 14. If this has a mass of 12, how many protons does it have? 6. How many neutrons does it have? 6. How many electrons does it have? 6. Okay, so now, Ladena, ready? You've got 6 protons. That's this number right here. The neutrons come from when you subtract these two. Because this number, 12, is protons plus neutrons. This number is protons only. So this is protons and neutrons. This is protons. If I subtract them, I'm going to get neutrons. And then the electrons are because this number, 6, which was the number of protons, has to be equal to the number of electrons in a neutral atom. And this is neutral. We haven't done anything that's not neutral yet. When it's not neutral, there's going to be a number over here. Okay? All right. How many protons in this carbon? 6 protons. Doesn't change. Okay. How many neutrons in that one? 8. And how many electrons? 6. These are isotopes of each other. All right, I went off on a little tangent there, but yay. If we could find our paper again, where the heck did we leave it? Okay, the atomic number is the same as the number of protons. Where is most of the mass located, Michelle? Do you know? Somebody help her out. The nucleus. Okay? The nucleus is where the protons and the neutrons are living, and they are the only thing that has a mass. Do you remember what the mass of a proton and a neutron is? 1. Uno. Uno AMUO. How's my Spanish? Okay, 1 atomic mass unit. 1 atomic mass unit is based on a carbon 12. 12 divided by 12 gave us 1. That's how they defined it. It's 1/12 the mass of something that weighed 12. I don't know, it's weird. All right, which particles account for the mass of the atom? We just said that. Those are the protons, which have the mass of 1 AMU, and neutrons, which have a mass of 1 AMU. Kanak, you good? Okay. I'm going to go to the next page because I want to be able to move it up there. Okay. If you have something that has atomic number 9, you need a reference table. Okay? If you have something that has atomic number 9, what element is it, Izzy? Fluorine. Okay? There's a common thing that she just said. She said fluoride. Fluoride is when it is in a compound. Fluorine is if you're just talking about the element. Okay? That's the difference. All right, so we got atomic number 9. If there's an atomic number of 9, Olivia, how many protons does he have? 9. 9. How many electrons does he have? 9. Okay. Now, Isaiah asked me a good question before. If you go to your reference table, let's go find a reference table, and we go to fluorine, which is over here. Fluorine is a very popular element on the periodic table. Here it is. Okay, let's find him again. There he is, fluorine. Okay, you've got a number there. That number is not the mass number. It is an average atomic mass. It is an average of all the fluorines in the entire world. Do you think some scientist in a dark basement is sitting there counting fluorines? No, they're not. Okay? So what they're doing is they're taking percentages, which you're going to see when we start doing some math, and we may get to that today. They're taking percentages and they're saying, all right, we've got a lot of fluorine 19s and we've got a few fluorine 18s. So therefore my average is going to be closer to 19 than it is to 18. And so you can see here we have 18.9984, which is closer to 19 than it is to 18. I gave you my example about, I think I used you, Ashley, right? Didn't I say that you took 4 tests or 5 tests? And no, I didn't? Okay, let's do that. So let's say we have Ashley. Here she is. We're going to pick on you, right? And we've taken 5 tests in this class. The first test, she got 100. Pretty good. Second test, she got 100. Hey, she's a good student. Third test, she got 100. Fourth test, she got 100. Fifth test, she got a 20. Had a bad day. Okay? Now, I have to do the report card. And I look at that and I'm like, oh, crap. The last test she took, she got a 20. I'm going to give her an average on a report card of 25. Is that fair? Why not? Oh, you just pick on poor Ashley. We should have made him get the 20.
20 is like crazy.
I know. This is all made up. This is not her real.
Still fair.
So you think I should give her on her report card a 20? Should I give her 100?
No.
No. I should probably give her somewhere around an 80, right? Her average on her report card should be closer to what? I don't know what that was. Should be closer to 100 because she has 80% of the time gotten 100 and 20% of the time only gotten a 20. And when I say percent of the time, look, it's 4 out of 5, that's 80, and 1 out of 5 is 20. It has nothing to do with these scores. Okay, it just happened to be the same just because. So her average had better be closer to the 100 than it is to the 20. That's what's happening here. Let's say I have fluorine 19 and fluorine 19 and fluorine 19 and fluorine 19, and then I have one fluorine that's a fluorine 18. 80% of the time I've got a fluorine 19, but only 20% of the time I have a fluorine 18. What's my average going to be closer to? Closer to the 19. And if you look at the periodic table right here, see how it's closer to 19? It's saying that most of the time I've got fluorine 19s. So I can look at the periodic table and figure out what's the most abundant isotope in the universe because the average is going to be closest to that. So what do we have the most of for, let's say, sulfur? 32. Are there sulfur 33s? Yes. Are there sulfur 34s? Yes. Okay. Oxygen. Is there such thing as an oxygen 12? Yes. But what are most of the oxygens in the world? 16. So if we need to figure out number of neutrons, we're going to just use the most abundant one unless they tell us to use something different. Like let's say they say oxygen 17. Okay, this 17 is the mass number. Oxygen 17. These are the same. What is the number of neutrons in oxygen 17? Well, you know what this number is, right, for oxygen? It's 8. So the number of neutrons in oxygen 17 is going to be 9. Okay? It is not the most common one, but they told us the mass number, so that's what I'm using. If they said, what's the number of neutrons in oxygen, and they don't tell us anything else about it, then I would use the one that's right off the periodic table. Okay? See the difference? All right. Let's go back to this. So this fluorine, let's make the mass the 19. I don't want it to. Let's make it the 19. And how many neutrons is it going to have? 10. Okay. What element is this P? Phosphorus. I wrote it in a very bright pink, but my pen is very, very big. All right. What's the atomic number of phosphorus? 15. How many protons does it have? 15. How many electrons is it going to have? 15, because we're still dealing with an atom. What's its mass? 31, which means this is going to be 16. What are you doing? You're distracting me. All right, the atomic number is the number of protons. Okay, in an atom of in one atom of the element, it is also the number of electrons in a neutral atom. The atomic number gives the identity of the element, and no two different elements will have the same atomic number. They're going to be, if they have the same atomic number, they are the same element. The blank of an element is the average mass of the element's naturally occurring atoms. What is the average called? Atomic mass. And it takes into account the blank of each isotope. What is it taking into account? There's a couple words you can use here. I don't care what word you use. Not the mass.
Number.
Nope.
Amount.
The amount. Okay? The amount of each isotope. It also takes into account the percent of each isotope or the abundance of each isotope. They use that word, so I want to put it out there. Okay? So they could say 50% of the time you have this and 50% of the time you have that. Find the average. That's where we're going. In order to calculate the number of neutrons, you must subtract the what from the what. Okay, I like it. The protons, which is also the atomic number, from the atomic, I'm going to change it to mass number because I want it to be a whole number. Mass number. Or the average atomic mass rounded. And then finally we have these three things: lithium, mercury, and iron. Let's get a paper. Okay, what's the symbol for lithium?
Li.
Li. Don't lie. Okay. How many protons does lithium have? 3. Where does it go? Haley, where do I put that 3 on this symbol? Haley? Bottom left. Okay. And what is its mass number? I like 7. Does that mean there's no other lithiums out there? No, but this is the most abundant one. Okay, what was next? Mercury? Okay. What's the symbol for mercury? Hg. Okay. What is the atomic number of mercury? 80. What is the mass number of mercury? Okay. I don't know what it is off the top of my head, but I'm assuming it's about that because it's heavy.
Yeah, it's 225.
All right, so it's 201. It's close enough. Okay. And then finally we had iron, right? And the symbol for iron is Fe. What's the atomic number of iron?
26.
You got out of that one, Cody. Okay. It's 26. What is its mass number? 55 point something. So let's go with 56.
It's 50. Oh yeah, it's 50. Yeah.
Okay. Any questions on this paper?